Hello students, in today's session I am going to discuss what is object-oriented system development, then different models used for object-oriented system development like waterfall model and spiral model, and last concept object-oriented construction. Now, object-oriented system development. Development refers to software life cycle, that is analysis, design and implementation phase of any software system. System development process is considered as a sequence of well-defined activities that done throughout its life cycle. Object-oriented development approach encourages software developers to work and think in terms of application throughout the software life cycle. Object-oriented development is a conceptual process independent of a programming language until the final stage of a software system. There are various models for construction of software system. So here system development, it is the process of defining, designing, testing and implementing a new system. Gather all the requirements for a problem domain, go through various activities and there will be a formation of new system. Object-oriented system development is get divided into three phases. Phase 1, object-oriented analysis. In this stage, the problem is formulated, users are giving the requirements, means users' requirements are identified and the model is built based on the real-world objects. The analysis produces the models on how the desired system should function and how it must be developed. The model does not include any implementation details. So in first phase, that is object-oriented analysis phase, the requirements are gathered and then that requirements are get modeled or get designed. Then second phase is phase 2, that is object-oriented design. It is get categorized into two parts. One is system design and second is object design. Now system design. In this stage, the complete architecture of the desired system is designed. The system is conceived as a set of interacting different subsystems that will be composed into one whole system. A different hierarchy of interacting objects are grouped into the classes. System design is done according to the both system analysis model and the proposed system architecture. Here the major emphasis is given on the objects. Then second substage is object design. In object design phase, a design model is developed based on both the models developed in the system analysis phase and the architecture designed in the system design phase. Here necessary classes are going to be identified. So in phase 2, a system architecture is formed and necessary objects are identified, necessary classes are identified here. Then phase 3. In phase 3 is object oriented construction or implementation. So what the design is formed in phase 2, that is get converted into the coding form. So in phase 3, the design is get converted into the coding form as per the appropriate programming language or software tools. Necessary databases are created based on and the specific hardware requirements are ascertained here. Once the code is in shape, it is get tested using specialized techniques to identify and remove the code's errors present in the code. Models of object-oriented system development. Here first I am going to discuss first model, waterfall model. There are different 6 phases for waterfall model. The first phase is requirement specification. In this phase, all the possible requirements of the problem domain is gathered from the customer. Then once that requirements are gathered, that requirements are get analyzed in second phase, and all the requirements are documented in requirement specification document. Then third phase is design phase. What the document is created based on the respective requirements. So based on that requirement specification document, the design of the system is prepared at this phase. This system design helps in specifying hardware and system requirements and also helps in defining overall system architecture. So system design is formed at the third stage or third phase. Then fourth phase is implementation phase. What the inputs are taken from the design phase that are taken and that are converted into smaller programs, or based on that smaller programs are developed. That programs are say as units. All the units are tested for their functionality. For that purpose, unit testing mechanism is applied. Then next phase is integration and testing phase. So in implementation phase, smaller programs are developed that are say as units. Then that smaller units are get integrated at this fifth phase, that is integration and testing. So like this, smaller subsystems are formed and later on the whole system is formed. So when the units are get integrated, at that level integration testing is applied, and after that the post integration phase, that is entire system is going to be tested for any faults or failures occur in that system or not. Then next phase is maintenance phase. Once the product is ready, that product is delivered to the customer, there could be some errors at client environment. So that errors are going to be identified in maintenance phase, and then that error or problems are to be fixed for those issues, and different patches are released here. To enhance the product, some better versions are created and released for that software system. So here maintenance is done to deliver these changes in the customer environment. So these are 6 different phases of waterfall model. At first phase, gather the requirements. At second phase, analyze that requirement and prepare requirement specification document. At third phase, what the requirement specification documents are giving requirement, based on that system design is prepared. Then based on that system design, in implementation phase, smaller units are developed and that units are tested. Then at next stage, that is integration and testing, the smaller units are get integrated and subsystems are formed and tested at that level, and post system testing is also done here. And final phase is maintenance phase. Here the in maintenance phase, the any changes are suggested by the users or any problems are occurred at customer side, that are going to be resolved. So these are the different phases for waterfall model. Now, when to use waterfall model or SDLC model? There are certain situations where we can apply this waterfall model. If all the requirements are fixed, the requirements are not frequently changing, then we can use waterfall model. Application is not complicated and big enough. In simpler applications we can use waterfall model. If project is short, then only we can use waterfall model. All the requirements are clearly mentioned from customer side, then only we can use waterfall model. The technology and tools used are stable. In that scenario, we can use waterfall model. All the resources are available and trained, then only SDLC model is used. Now, advantages of waterfall model. Before the next phase of development, each phase must be completed. For example, first phase is requirement specification. So all the requirements from the client side should be given. Once this phase is completed, then and then only we can switch to the second phase, that is analysis phase. So every phase must get completed at that level. Then waterfall model is well suited for smaller projects. Complex applications could not be developed with this model. It should be perform the quality assurance test like validation and verification phase before completing each stage. Elaborate documentation is done at every phase, means every phase will produce certain document by that respective team members. There is minimum client intervention while working with this particular model. Any changes are with a system that is done during the process of development. Now, disadvantages of waterfall model. Error can be fixed only during that respective phase. It is not desirable for complex project where the requirement changes frequently. Means all the requirements should be given at initial stage, then and then only we can use waterfall model. If requirements are frequently changing, then in that situation waterfall model is not sufficient. Testing period comes very late in the developmental process. Much of the time is consumed with the documentation, and very later on the development stage starts. That is, documentation occupies a lot of time of developers and testers, and very late phase for the implementation and testing. Clients' valuable feedback cannot be included with ongoing development phase. Means at the initial stage only the client could give all the requirements, and that will be converted to the analysis phase. Small changes or errors that arise in the completed software that may cause a lot of problems. Means changes could not be easily adapted with waterfall model. So these are the certain advantages and disadvantages of waterfall model. Now, second model for object-oriented software development is spiral model. In earlier slide, we have discussed about what is waterfall model, what are advantages and disadvantages of waterfall model. Certain disadvantages are overcome in this model. This is a model that has been proposed by Bohum. As the name suggests, the activities in this model can be organized like a spiral. The spiral model describes how a product develops to form new version, and how the version can be incrementally developed from prototype to a completed product. There are four major phases of spiral model. First phase is analysis phase, second is design phase, third implementation phase, and fourth one testing phase. Now, phases for spiral model. These are the four phases: analysis, design, implementation and testing phase. First phase, analysis phase. This phase starts with gathering the business requirements in the baseline spiral. In the subsequent spirals, as the product matures, identification of system requirements, subsystem requirements and unit requirements are all done in this phase. This phase also includes the understanding of the system requirements by continuous communication between customer and system analyst. Once all the requirements are gathered, then second phase is design phase. This phase starts with the conceptual design in the baseline spiral and involves architectural design, logical design of modules, physical product design and final design in the subsequent spirals. Then third phase is implementation phase. This phase refers to a production of actual software system at every spiral. In the baseline spiral, when the product is just thought of, a certain design is being developed, that is, a proof of concept is developed in this phase to get the customer's valuable feedback. Then in the subsequent spirals, with higher clarity on the requirements and design, detailed working on the model is done and according to that the software is built. Then the fourth phase is testing phase. The testing phase includes identifying the errors and faults of the system and according to that the bugs are get fixed in this testing phase. So these are the major phases of spiral model. Different versions are created for the end product. Now, when to use spiral methodology? There are certain situations where spiral model is applicable. When the project is too large or complex, we can go for spiral model. When releases required to be frequent, different versions are created with this spiral model. When creation of prototype is applicable, then we can use this particular model. When risk and cost evaluation is important, in that case also we can use spiral model. For medium to high project risk, we can prefer spiral model. When requirements are not clear and requirements are complex and frequently changing, in that case spiral model is preferable. When changes may required at any time, that changes could be adapted at any phase and applied in development. When long-term project commitment is not feasible due to changes in economic priorities, in that case also we can use spiral methodology. Now, advantages of spiral model. Any new functionality or any type of changes could be added at later stage also in spiral model. Cost estimation becomes easy as the prototype is built and is done in a small fragments, that is in spirals. Continuous or repetitive development helps in risk management also. Development is fast and features are easily added in systematic way. There is always a space for customers' valuable feedback. Any suggestions are given from customer side that could be adapted and that could be implemented at any stage. So these are the certain advantages of spiral model. There are some disadvantages of spiral model, that are risk of not meeting the schedule or budget, means the project could not be completed in a defined schedule sometimes, or budget may get rise. It works best for large projects only, also demands a risk assessment expertise for assess the risk. For its smooth operations, spiral model has certain rules and regulation or protocols. That protocol should be followed strictly in the different phases of spiral model. Documentation is more as it has a certain intermediate phases. It is advisable do not use spiral model for smaller projects because the cost may get rise for smaller projects. So these are the certain advantages and disadvantages of spiral model. Now the term object-oriented analysis. There are 5 different phases for object-oriented analysis, that are finding the objects, organizing the objects, object interaction, operations on objects, and object implementation. Before that, what is object-oriented analysis? Object-oriented analysis is the procedure of identifying software engineering requirements and developing software specifications in terms of software's systems object model, which comprises of interacting objects. In object-oriented analysis, the requirements are organized around the objects. Grady Bush has defined object-oriented analysis as it is a method of analysis that examines requirements from the perspective of classes and objects found in the vocabulary of any problem domain. Now, the primary task in object-oriented analysis. First task is finding the objects. Objects can be found in the application domain as naturally occurring entities. Finding the objects is not a difficult task. We can easily get that. But from that, selecting the relevant object is somehow a difficult task. Relevant objects means the objects which remains throughout the system's life cycle and which are useful in that system, that objects are say as relevant objects. So only relevant objects should be chosen at the first phase, that is finding the objects. Second task is organizing the objects. Once the objects are identified, then to organize the objects and classes of objects, we have to use different criteria. One of the criteria we can say inheritance. Through inheritance, we can show the relationship between the objects. For example, from class A, we are deriving a new class B. So we can show A and B as a related class and we can show their organization. Like this, there are different criteria which could be used for showing the organization of the objects. Then third task is object interaction or object communication. To get a clear idea of objects' role in the system, we can use different use cases in which objects takes part and communicates with each other. By this, we can describe objects' surroundings and exceptions of other objects. We can show the communication between the objects through object interaction. Then fourth task is operations on objects. The operations on objects can be directly identified from the applications. The operations on objects comes naturally when we consider the object interface. For example, I have identified the object as a customer. For customer, I could write the operations like add customer, delete, modify. Like this, any operation could be possible on the customer object. Then fifth task is object implementation. The object has to be defined, which includes the which defines the information that each object must hold. Means actually we can go for design of a class and we can say a coding part of that object. So these are the 5 primary tasks of object-oriented analysis. That is finding objects, organizing objects, object interaction, operations on object and object implementation. Now, object-oriented construction. The first phase is gather the requirements. Then that requirements are get analyzed. For that, requirement specification document is prepared. So, analysis to source code is nothing but object-oriented construction. Means analysis, then design and then the coding phase. that could be say as a object oriented construction. I repeat, gather the requirement, analyze that requirement, form the design for that requirements, and from design we can go for a coding phase. So from analysis to source code generation is nothing but object oriented constructions. Transform analysis mode into design model and then to implementation model. Means from analysis to design phase and from design to implementation phase can be say as object oriented construction. The objects are identified during analysis phase, may be implemented during construction phase by using previously developed source code. So this could be say as object oriented construction. So here is the end of this presentation. In this lecture, I have discussed about what is object oriented system development, then different phases for object oriented system development, two major models, that is waterfall model and spiral model, their advantages and disadvantages, then object oriented analysis and object oriented constructions. So I hope you understand the basics. Thank you. Have a nice day.